So, hello everyone, welcome to CivilPrep. I am Krishna Gupta. So, this is a session with respect to MentorCase, where we'll be looking at geography optional case studies. In total, 1000 case studies, which is an initiative. Okay, now, case studies. Why it is important? It is seen that when majority of the students who write mains exam, they are either having difficulty in recalling examples. If they know certain examples, they miss certain data. If they have certain data, so they struggle to find their sources. And where to apply this example data and sources to a basic scenario in terms of a case. So if the case, it is missing, this may result into the decline in marks. This may result into the decline in marks scored. So because of the declining of marks, the students, they are unable to find that what is the reason. So to overcome this issue, where students, they find difficulty in making cases or adding cases to their answer, we have started here a case study program, okay, at CivilPrep in the name of MentorCase, where we will be covering case studies for both paper 1 and paper 2 of geography optional exam. These case studies are very much relevant for paper 2, that is Indian geography. Where we need the case studies for almost every question. Okay. Apart from this, we'll be also saying that the case studies are also relevant for paper 1, where we look at certain questions like recent context or recent example, with respect to application of models like central place, Rostov's model, possibilism, determinism, environmentalism, radicalism, behavioralism, etc. So here we'll be seeing that these cases are very much helpful to look at these aspects, okay, to put recent examples from the perception of geography optional exam with respect to the various perspectives, models, theories, laws, or just an example also. Now, moving to the first case we have today, that is the heat stress and vulnerability. Okay, so this heat stress and vulnerability, this is seen from the perception of rising occupational risk in rural area. So here we'll be seeing that the context is provided. That is the recent context. Here, the climate change and global warming, they have driven the extreme temperature increase. So in the year of 2025, the temperature in northern and central India is seen to have soared to around 45 to 48 degrees Celsius. Okay, which is basically affecting over 60 million agricultural workers. Okay, not only this, the reports also indicate that this report is basically provided by Indian Meteorological Department. So this report also highlight that a 35% surge or increase in heat related illness, okay, for the people who are working outdoor. Now, if you look at the recent systems here, so we can look at this context. Okay, this is basically a case which we can see here, which is seen in the northern and central India. If I draw a map here, so here the region of northern India and central India. So this northern and central India, it is being gripping under the heat wave. Okay, this data is of 2025. Okay, this temperature here, it is almost around 45 to 48 degrees Celsius, covering the areas like Rajasthan, then Uttar Pradesh, Madhya Pradesh. Okay, we can see certain regions here from Haryana and also Punjab. So these regions we can see they are grappled under the heat wave. So if we look this from the geographical perspective, we can apply here number one, environmental determinism. Okay, under environmental determinism, the climate, it is influencing human health in terms of heat stroke, and number two, the economic activities. Okay, so if we try to apply the theorist here, so the theorist we can apply here, that is Redzel and Huntington. Apart from this, we can also see here a spatial clustering model. This spatial clustering model, it is used to identify hotspots of heat waves by using the GIS, that is Geographical Information System principles. Here, if we try to apply the system model here, so it will be systems approach, which is developed by Barry and Shorley. Apart from this, we can also apply here the regional synthesis. Okay, regional synthesis as propounded by Hetno. Okay, where we are dividing northern and central India to study the effect of heat waves. Okay, so this is one of the part which is quite important here to apply. Now, when we look at the real world solutions, under this we'll be seeing that we need to have certain heat action plans. Okay, we need to have certain heat action plans in terms of number one, we can see the staggered working hours. Okay, which we can see from the locational analysis. Okay, apart from this, we can also see the hydration checkpoint. Okay, where we need to see the physiological adaptation of human beings, where we can apply the law of tolerance, which is propounded by Shepard. And we can also apply here the limiting factor, which is given by Liebig. Okay, so through this we will see that we will be able to overcome this condition. Now, if we look at the example where these two conditions have been applied, so here we have an example of Odisha. So in Odisha, we'll be seeing that the heat-related illness it is declined from over 35% to 28% over 3 months. Okay, so this is one part, or this is one data which is given by Odisha state government health data here. Okay, so this is the first case we can see from the perspective of the heat stress and its vulnerability. Now, this heat stress case study, it is taken from down to earth. Now, next case study here we have, that is the heat stress effects on crops. Now, what we see here, that the productivity of the crops under the heat stress condition, it declines. Okay, so same condition is seen in the region of Punjab and Haryana, which are part of the northwestern India. Okay, here we'll be seeing that there is almost, we can say that a decline of around 20% in yields have taken place for crops like rice, wheat. Okay, and the major cause here is, it is reduced soil moisture. Okay, so we can interlink this cause with respect to reduced soil moisture with potential evapotranspiration, that is PET, and number two, moisture index, and number three, heat index. Okay, so we can include these parts here with respect to this reduced soil moisture and its impact on rice and wheat. Okay, here we'll be seeing that the region of Punjab and Haryana, it is coming under the temperate and subtropical region, which is very significant for the growth of wheat crop. Okay, now when we will look at data here, so the soil moisture loss, it is significantly dropped by 15 to 20% in affected areas. If we look at from the geographical perspective, so number one, the Punjab and Haryana region, it is coming under the semi-arid region, where the rainfall is ranging between 52, or we can say here 25 to 75 centimeters. Okay, now this is the first part here. Second part we can apply here from the perspective of environmental determinism. Okay, where the adverse weather conditions directly lowers productivity. Okay. Now, here we'll be looking at the theory. It is propounded by Retzel and Huntington. Okay. Now, apart from this, what also we'll be seeing here that this particular region of Punjab and Haryana, it is also undergoing a condition of climate change, which is witnessing almost 1.5 degrees Celsius rise in temperature from pre-industrial levels. Okay, this is an important aspect, and this data it is provided by UNEP. Also, it is confirmed by IPCC. Okay, so this is an important uh, region here we can see that is affected because of the decline in soil moisture, where the evaporation it is higher than precipitation. This is also resulting into a condition where the soil salinity it is increasing. Okay, so this is also one of the issue, one of the factor which is seen in the region of Punjab and Haryana. Now, looking at the real world solutions, here we can see number one, enhanced irrigation, to maintain soil moisture. Okay. Now, number two, the drought resilient seeds, which is taken up under the initiative of climate smart agriculture, which is taking a quote from techno-centric approach, that is development of seed, that is drought resilient, or the approach can also be taken from Gyanism, where identifying of drought resistant seeds from diverse crop ranges. Okay, so this two approach can be seen here, which is quite useful for making the seeds or making the crops drought resilient. Okay, so this is applied over the region of Haryana. Example, application over the region of Haryana, where it had resulted into the improved irrigation, okay, which increased the crop yield. Okay, by almost 12%, reducing the initial fall from 20% to just 5%. So this is an achievement we can see that has happened in the region of Haryana here. Okay, so this is one of the cases. This is another case with respect to the impact of heat resistance or heat. We can say the heat stress over the crop and crop productivity. So this is the second case. Third case here we have, that is the tectonic tensions and forecast frontiers. Now looking at this particular case, we'll be saying the Himalayan region of India. The Himalayan region, here we'll be saying that this is Eurasian plate. And this is the Indian plate. So because of the formation of multiple suture zones, we have the presence of Himalayas here. Okay, so we can identify them as Trans Himalayas, Great Himalayas, Shivaliks, and Lesser Himalayas. So what we are seeing that because of the pushing of the Indian plate towards the Eurasian plate, and we know that there is no subduction is taking place. No subduction is taking place, and the pushing is being done from the rate of almost around 1 to 2 centimeters per year. Okay, it is done around 1 to 2 centimeters per year. So because of this condition, what we are seeing that there is an increased risk of seismic activity. In the Himalayan region. So there is a model which is provided with respect to 2025 probabilistic hazard assessment, which specifies us a 25% higher chances of earthquakes greater than 6 magnitude. Okay, which will be coming in the future or coming years. Okay, so what we can see here that there is an evidence for this particular aspect. When we look at the evidence, in the region of Himalayas, that is Uttarakhand, Himachal Pradesh, even New Delhi, Arunachal Pradesh, Assam, Sikkim, etc. They have started to feel frequent minor tremors. Which is more than 3 per day, which is high in number. Okay, so this is providing us a condition of instability in the region. So here we see that this data source is provided by National Center for Seismology. Okay, this data is provided by National Center for Seismology. Now we will see that from the geographical perspective. Number one, the plate tectonics. If we will look at the case of the Himalayas, they are young fold mountains. Okay, here we'll be seeing that the Indian plate, it is pushing Eurasian plate, resulting into the formation of stress between the plates. Okay, this stress in future will result into the formation of faults and further folds. This faults, it will result into the release of energy. Okay, so this we see here from the plate tectonic perspective, where we see the kind of convergence motion is taking place between the continental and continental plate. Okay, now this theory of plate tectonics, it was provided by Tuzo Wilson. Then we have Morgan and Mackenzie. Okay, now this part, it was also explained with respect to the formation of Himalayas by Alfred Wegener, which can be seen from the perspective of continental drift. Okay, but this continental drift theory, it has been overtaken by the plate tectonics theory in the contemporary times. So if we look at the solution in the real world part, when we look at the real world solution, here we need an advanced early warning system. Okay, this advanced early warning system, it has been seen from the perspective of one of the satellites which is jointly now launched by India and NASA, which is called as NISAR. Okay, the NISAR satellite system, which is consisting of high resolution optical spectrometer. This has a high resolution optical spectrometer. It will be able to identify the faults and the changes in faults. And on the basis of this, it will be able to identify the seismic gaps which are present in the Himalayan region. So here we can see that the technologies in terms of the chorology plus chronology plus we can see systems analysis plus hazard zonation will be used here to tackle this problem of earthquakes in the Himalayan region. So this technology, it is being applied in the region of United Uttarakhand, where we'll be seeing that the system and the application of the system have resulted into the 30% minimization of disasters. Okay. Plus, we can also see the damages are also reduced by almost 18%. Okay. This data it is provided by disaster management agencies, that is NDMA. Okay, so this is one of the solution which we can see is important for solving the problem of tectonic tensions and forecasting the frontiers where the disaster can occur in the future. Okay, next case here we have from the science diplomacy. Okay, from the science diplomacy. Here it is linking environmental science and policy. Now here we'll be seeing that the global environmental challenges have spurred science diplomacy as nations collaborate to tackle the transboundary issues. Thus, in June 2025, an international summit okay, which was done under UNESCO Global Ministerial Dialogue. Okay, it has specified joint pollution control projects. Okay, basically for improved transboundary air and water quality. Okay, when we look at the certain statistics here, we will see that the pollution reduction, okay, here we see that the collaborative projects of the world, it has lowered the pollution levels by almost 15%. This report it is provided by World Commission on Environmental Development part here. Similarly, the water pollution, it has almost reduced the pollution level by 10%. Now, apart from this, when we look at from the geographical perspective, number one here will be seeing that the sustainable development model. Okay, this is basically fusing the environmental science with the policy actions. It is integrating environmental science with policy actions. Okay, here we can refer this particular report to the Brundtland Commission. Which has given, which was formed under the World Commission on Environment and Development. Okay, apart from this, we can also add up here environmental determinism, which is seen in the contemporary time by Huntington. Okay, also the various laws and protocols highlighted by UNEP, UNCCD, UNFCCC, also by CBD, that is Convention on Biological Diversity. Then we have Stockholm Conference. Okay, here also we'll be seeing that we have Montreal Protocol, we have Vienna Protocol or Vienna Convention, we also have here Basel Convention, okay. So here we can see the various conventions, laws and protocols which are helping to reduce the pollution and pollution levels in air and water. Okay. When we look at the real world scenario, when we look at the real world solution, here we can see that there are certain joint environmental projects have been implemented. Okay, this joint environmental projects, they are cross-border initiative focused on managing shared river basins. Okay, we can see an example, that is India-led initiative for water quality in Ganga, Brahmaputra, and Indus River, where it is reducing transboundary pollution by almost 15%. This is a very big number. Okay, so here this report, it is provided by UNESCO Dialogue Outcomes and Transboundary Project Report. So guys, this is one of the case study which is providing us the science diplomacy, that is linking environmental science and policies for the reduced pollution. Now, just tell me that which law has been provided by India or enacted by India for reducing air and water pollution. So when we look at from the perspective of India, we have Air Act and we have Water Act. It is okay. So Air Act and Water Act, it have been passed in India to specify that how India it is fighting with the air pollution and the water pollution. Okay, so guys, these were certain cases, the case studies from the perspective. Okay, this is also taken from Down to Earth, June magazine. So in the next class, we'll be moving to the next cases, which will be taken from various other magazines. So guys, good day for today. See you in the next class. Thank you very much.